Okay, so we're ready to start the next topic. It's all part of 2.7. It's part of homework number 10. So let's get to our usual. And let me put up the topic up there on top, the name of the topic. Here we go. So we're talking, here's its fancy name, piecewise defined functions. I think you're going to see that there's just a fancy name. There's nothing really special about this topic. Piecewise, and it denotes that it's going to be in pieces. That's why it says piecewise. It's going to be in pieces. Give me a chance to explain. Let it all play out. Piecewise defined function. Okay, so it's just a fancy name. There's not going to be really all that special. Here's what it looks like. Problem number one, and that's all we really need. F of x, here's the given, right? Here's our given, right here. F of x is equal to negative x minus 1 for the following values. Negative 4, x is going to be in between negative 4 and also equal to negative 4 and up to negative 1. It's going to be equal to the number negative 3 for the interval that x is between negative 1 and I'm sorry, over here, I meant to write that this should just say negative 1. Not negative, less than negative 1, not less than or equal. Now, x is between negative 1, and it could be equal to negative 1, and 2, just the plain 2, not equal. And the last part is that it's going to f of x is going to be x plus 2 for x is greater or equal to 2. All right, so let me show you 3 questions. Here's question A. We want to know the question A is, what is f of negative 3? F of negative 3. These are the questions. These are questions. A. B. The next question is B. What is f of negative 1? Right? Negative 1. And C. What is f of 6? C. What is f of 6? Okay, so if f of negative 3, we look up over here. F of negative 3, we look up over here. Where's negative 3? Negative 3 is between negative 4 and negative 1. Negative 3 is somewhere in between here. It's above negative 3. It's below negative 1. So it's over here. So what are the instructions? The instructions say negative x minus 1. So let's do negative 3. That's what x is. X is negative 3 minus 1, which is equal to positive 3 minus 1, which is equal to 2. And here's the answer. This is the answer right here. Now, let's take, this is question A. Question B. What is f of negative 1? So we look over here. Where's negative 1? Negative 1 is here. This is one. This is where negative 1 is. Negative 1, less than negative 1, but not equal to negative 1. But if it's equal, negative 1, it belongs over here, between negative 1 and 2. All right, what is f of, when it's going to be negative 1? What's the value? What are you supposed to do? The answer is negative 3. Problem over. This is the answer. You just write negative 3 for all those values. That's the answer. And now finally, f of 6. So is 6 over here? Is x equals 6 over here? No. Is it here? No. But greater or equal to 2? Well, 6 is greater or equal to 2. 6 is greater or equal to 2. So here's what we're supposed to do. X plus 2. So we take x becomes 6 plus 2 equals 8. And the problem is over. That's all you got to do. There's nothing more special than that. It's nothing more special than that. Okay. Now we have more space on this piece of paper, so we can go to the next topic. Due to the fact that we have more space on this paper, we can go on to this next topic. Here is the next topic. The next topic is determine the intervals, determining intervals of a function where it is decreasing. Is it decrease? Is it increasing? Is it increasing? Decreasing? Decreasing? Or constant? Constant. Okay, here's the function. It looks like this. The y-axis, the x-axis, as usual. And over here, this is -1, -1, -2, -3, -4. Here is 1, 2, 3, and 4. This is 1, 2, and 3. And here's what the function looks like. Right over here, there's a little circle, and it's filled in. It's filled in. Okay. And it goes, this thing goes down also, so it goes down to -1, -2, -3. Okay, so now this is going to go as follows. It's moving down, right over here, right there. Then it's going to move across like this over here, and then it goes up like this, and then it goes down like this. Okay, now here's how it works. If it's down, left to right, then it is decreasing. Sorry, then it is decreasing. If it is, forget this, if it is up, left to right, then it is increasing. And if it is level, like this, then it is constant. Okay, so now the interval -4, between -4, including -4, until you get to -1, including -1, on the x-axis, it is decreasing. From 3 to infinity, right, it is decreasing. From -1 until you get to 2, because why did that happen? -4 to -1. Here it is going downwards, left to right. From 3 till infinity is downward, left to right. Down, left to right. Down, left to right on this interval, and down, left to right on this interval. Between -1 and 2, it is obviously on the x-axis. It is constant. Here we are between -1 and 2 on the x-axis. It's just level. It's constant. It's level. And finally, between 2 and 3, on the x-axis, it is increasing. It's going upwards from left to right. It's going upwards, up from left to right. That is the topic of decreasing, increasing, or constant on the x-axis of a function. Okay, so that wraps that up.